With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, it is given that there is an ideal gas which take part in two thermal processes in which it is heated from the same initial state A. Once it is taken from A to B and in the other process from A to C. That means this initial condition is same. Now in one of the process, it is taken from A to B and from another process, it is taken to this A to C. Now B and C, they are lying on the isotherm. Now what does isotherm mean? Isotherm basically means same temperature, or we can say that temperature would be constant. Okay, so this is the curve in or at which temperature would be constant. So we can say that if temperature here is T, so the temperature here would also be T. Okay, now initially let's say here the temperature is, let's say T naught. Okay, initial temperature is T naught. So for AB, what is the value of the change in temperature? What is the delta T value? Okay, so we can say that T minus T naught. Now this would be same for this AC also. So delta T would be equals to T minus T naught. Okay, so we are just comparing with the initial temperature. Now if delta T is same, we know that for an ideal gas, delta U, change in internal energy, is a function of what? It is a function of change in temperature. We can say that it would be NCV delta T. Now if the delta T is same, so we can say that our delta U would be same for the part AB and as well as for the part AC. Why? Because change in temperature is same, so therefore change in internal energy would be same. So we can say that in both the process, delta U would remain same. Now also we need to find in which of the process, A or B, the heat supplies is greater than or less than or equal to as that of A to C. Now we know that using first law of thermodynamics, we can say that Q would be equals to delta U plus W. Now delta U is same for both the cases. That means if work done in AB is greater than work done in AC, then we can say that QAB would be greater than QAC. Okay, and if work done is less than, okay, if work done in AB is less than work done in AC, so we can say that heat would be less than, and if they both are equal, then we can say that heat transfer would be equal in the AB and as well as in the AC, in the AB as well as in the AC. Now first of all, we just determine what is the value of the work done. Now this is an isothermal process. What is the equation of the state for an isothermal process? We know that PV equals to constant. Okay, because PV equals to nRT, temperature is constant, so it would be PV equals to some constant. Or we can say that pressure would be equals to some constant divided by V. We can write it like this. That means at this point, what would be the pressure? We can say that it would be C divided by V, the volume at this location. What would be the pressure at this point? We can say that C divided by the volume of C is a constant. Okay, C is just a constant divided by the volume at the point of C. Okay, so this would be giving us the pressure. Now we just take an arbitrary point. We just take a point here, so we can say that this is one of the process. Now in this process, our pressure is C divided by V. Okay, at this point, the pressure, if we just look at the pressure, it is C divided by V. Now what is the initial pressure? We say that initial pressure is P naught. What is the initial volume? We say that initial volume is V naught. Okay, now what is the volume at this point, which we have taken the arbitrary point? So we can say that volume would be equals to V. Now what would be the work done for this process? So we say that work done would be the area of the curve. Okay, area under the PV curve. So what is this figure? This is a trapezium. So for the trapezium, what is the work? Work would be equals to 1 divided by 2 into sum of parallel side. So this is one of the parallel side P naught and this is another parallel side C divided by V. So sum of parallel side multiplied by the distance between the parallel side. So this is the distance which is equals to V minus V naught. Now if we just calculate the work done using the same thing, so we can say that work done, it would be equals to 1 divided by 2 sum of parallel side P naught plus C divided by V multiplied by distance between the parallel side V minus V naught. Okay, now if we just differentiate this expression with respect to volume, so dW divided by dV, and we can just check whether this is coming out to be, slope is coming out to be equal to 0 or greater than 0 or less than 0. So 1 divided by 2. Now first of all, we take this as to be a constant, so P naught plus C divided by V, we take it to be a constant and we differentiate this. So here if we differentiate, it would be just 1 because V naught is a constant, plus now we take this as a constant V minus V naught and differentiate our first term. So we can say that P naught is a constant, so differentiation would be 0 and differentiation of 1 by V is equals to minus 1 by V square. So it would be C divided by V square because the differentiation of 1 by V is minus 1 divided by V square. Or we can just rewrite our dW divided by dV. So this would be equals to 1 divided by 2. Now if we just multiply this, so it would be P naught plus C by V. Then if you multiply this V with this, so it would be minus C, V, 1 power would be cancelled, divided by V, and then minus and minus would be positive, C V naught divided by V square. Now this term and this term would be cancelled. So we get the value dW divided by dV. This would be equals to half P naught plus C V naught divided by V square. Now if we check this, all the term P naught, C, V naught divided by V square, these all are positive. That means slope is greater than 0. That means what? That means if we increase the volume, if volume is increased, then work would increase. Now if we see in the figure, which would have a greater volume, B or C? From the figure we can say that C is having a greater volume. So we can see that volume of C is greater than volume of B. Therefore work in the part AC would be greater than work in the part AB. Therefore heat in the part AC would be greater than heat in the part AB. So which would be the correct option regarding the heat? So in the part AB it is less than in the part AC. So with regards to our AB. So this is wrong. Here it is given that AB is greater, while we have seen that AC would be greater, and here it is saying that it is equal. So this is wrong because this AC is greater, or we can say that AB is lesser. So the correct option are A and C. Hope you understood the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.